Okay, guys, welcome back. Today is Unit 4. Even though Unit 4 is, we call it a packet, it's really just one section that we're going to bang out in one day. It's polynomial division. So we're going to learn how to divide polynomials today. This was covered by most in Algebra 2. So it's a little bit of a refresher. So in division, there's two ways to divide. The most common way is called long division, and long division can be used for any type of polynomial division, as you'll see. And then the synthetic division that you'll see below can't be used all the time, and so that's why in math, we tend to rely on long division 90% of the time. Anyway, enough of that. So we're going to, in the following problem, the directions seem really tricky, but I'll break it down for you. So it says, for the function h, use long division to determine whether each of the following is a factor of h of x. So what we're going to do, we have three separate problems here, A, B, and C. And we are going to, again, I do want to reiterate that I'm not, as you guys have noticed by now, I'm not big on writing steps down. So if you need steps, feel free to hit up Google, type in polynomial long division steps, and it'll break it down for you like that. So what we want to do is set up old school long division. We're going to see if x plus 5 goes into h of x. Now, it did ask a question. It said, use long division to determine whether each of the following is a factor. Now, remember, a factor, for example, like the number 35. Factors of 35 are 1, 5, 7, and 35. Factors are numbers that multiply or divide evenly with a certain number, and you don't get a remainder, okay? So we're going to answer yes, x plus 5 is a factor if we get a remainder of 0, or also known as no remainder, or we're going to put no, x plus 5 is not a factor if we get a remainder other than 0. So here's what we're going to do. We're always going to start off, the division part is always going to be dividing by x in this problem. So what we're going to do is, actually, let me clean this up a bit and color code it for you guys. So let me start off with the first part. X to the third power. X to the third power divided by x is x squared. So we'll put the x squared up above. Up above is where we start putting our answer. And now we're going to multiply x squared times x to get x to the third, and x to the second times 5 to get 5x squared. And then we're going to subtract it, just like old school elementary long division. Now I am going to bring down my next terms here. Bear with me here. I'm trying to color code to make it a little nicer for you guys. So when we subtract, the first term's just going to cancel. The subtraction will be the second ones, like negative x squared minus 5x squared will be negative 6x squared. Now what you want to do is bring down the next term, negative 17x. And then we're going to start over again. We are going to take the first term, which was the negative 6x squared. We're going to divide again by x. So negative 6x squared divided by x is negative 6x. And then we're going to go multiply by the x times 5, x plus 5. So negative 6x times x is negative 6x squared, and then negative 6 times 5 is negative 30x. So now we typically subtract, but since these are negatives, we're going to change them to a plus. Subtracting negatives, double negatives change to a positive. So it cancels here. And then you do your little bit of math. Negative 17x plus 30x is 13x. And then bring down your next term, that minus 15. So now we are going to divide again. We're going to do the first term divided by first term. 13x divided by x is 13. So we'll put a plus 13. Don't just leave a blank in between terms. At least put a plus, if not a minus. And we're going to multiply again twice. 13 times x and 13 times 5. So 13 times x and 13 times 5. And then we're going to subtract. First one's always going to cancel. And the second one, negative 15 minus 65 is negative 80. Now that guy, that negative 80, that's the remainder. So we have a remainder. Typically a remainder we write as a fraction, like minus 80 over the original x plus 5. So negative 80 is a remainder. So we're going to say no. X plus 5 is not a factor. It's not a factor of h plus x, and the reason is because it's simple. It has a remainder other than 0. Okay, let's try another one. Let's take x plus 1 now and see if that's a factor of h of x. So first term divided by first term, always. X to the third divided by x is x to the second. And then we always distribute, multiply twice. X squared times x is x to the third. X squared times 1 is x squared. And then show subtraction. These will cancel, and then do your subtraction. Negative x squared minus x squared is negative 2x squared. And then the next term, minus 17x, drops down. Now we start the process over again. First term divided by first term. What's negative 2x squared divided by x? It would be negative 2x. And then again, we're going to take that and distribute. So negative 2x times x is negative 2x squared. Negative 2x times 1 is negative 2x. Now we're going to subtract. We're going to change the signs. Subtracting negatives, double negatives change to a plus. So cancel these, and then add to get negative 15x. Now bring down your next term, the minus 15 at the end, and do the process again. First term divided by first term. Negative 15x divided by x is negative 15. Now we're going to take the negative 15 and distribute, multiply by each term. So negative 15 times x and negative 15 times 1. And then we're going to subtract, which changes to pluses, double negatives. Cancels, and these add up to 0. So we divided and got no remainder here. So we're going to say yes, x plus 1 is a factor of h of x. Okay, let's try another one. X plus 3. All right, first term divided by first term. X to the third divided by x is x squared. Then take it and multiply twice. X squared times x is x cubed. X squared times 3 is 3x squared. Then do subtraction. First one cancels. Subtract the x squareds to have negative 4x squared. Bring down the next term. And start over again with dividing first term divided by first term. They would divide to have negative 4x. So now we're going to multiply twice. Negative 4 times x is negative 4x squared. Negative 4 times 3 is negative 12x. And then subtract, which will change the negatives to a plus. These cancel. And we're adding down. Negative 5x. And then finally bring down the last term. And then divide again. First terms, negative 5x divided by x will be negative 5. And then take the negative 5 and distribute it. Negative 5x, and then negative 5 times 3 will be negative 15. And then these would cancel, actually change to pluses because it's subtracting negatives. And then we get a remainder of 0. So we would say yes, x plus 3 is a factor. Okay, let's get some more practice in. Number 3. For the function g of x, we're going to use long division to determine whether each of the following is a factor. So we're going to just do more practice here. I'll go a little quicker now. Could always rewind if I go too fast. All right, so we're going to start off with first term divided by first term. So x to the third divided by x is x squared. Put it at the top. And now we distribute. X squared times x is x to the third. And x squared times negative 4, negative 4x squared. Now, subtract, change the signs, cancel, add down. That would be 2x squared. And then next is bring down the next term, minus 11x. And then start dividing over again. Divide the first terms. 2x squared divided by x is 2x. So put 2x and don't leave a blank in front, put a plus. And then distribute. 2x times x is 2x squared. 2x times negative 4 is negative 8x. And then subtract, which changes the signs, cancel, and add. That would be negative 3x. Bring down your last term, and then do another round of dividing. Divide the first terms, negative 3x times negative 3x divided by x is negative 3. And now take the negative 3 and distribute it. Negative 3 times x, negative 3 times negative 4 will be 12. And then subtract, change the signs, cancel, and we got a remainder of 0. So we're going to say yes, x minus 4 is a factor. Okay, now let's see if x minus 3 is a factor. Okay, so let's start the cycle. Divide the first terms. X cubed divided by x is x squared. Distribute. X squared times x is x cubed. Negative 3 times x squared is negative 3x squared. And then change the signs to subtract. Cancel. Combine the like terms to have 1x squared. Bring down the next term. Now divide again. First terms, x squared divided by x is x. So put a plus x. Then distribute with the x. X times x is x squared. X times negative 3 is negative 3x. Subtract to change the signs. Cancel. Add. And then bring down the next term, the last term. And divide again. The first terms, negative 8x divided by x is negative 8. And then distribute the negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 3 is 24. And then subtract to change the signs. Cancel, and then we get negative 12. So we get a remainder of negative 12 over x minus 3. So we're going to put no. X minus 3 is not a factor because it has a remainder. X minus 1 we don't really need to go over. I hit 5 of the same things by now. All right, so the next part, don't be alarmed here. It is just doing, it says, in each of the following, a polynomial p of x and a divisor d of x are given. Use long division to find the quotient q of x and the remainder r of x when p of x is divided by d of x. Very fancy way of saying just divide and get me some answers and see if there's a remainder. So that's all we're going to do here. Now number 5 is going to have a little bit of a trickiness here. I'm going to show you how to set this up first, then I'll explain. Notice the x cubed minus 8 is missing in between the first term, or after the first term x cubed. It's missing an x squared and it's missing an x. When it's missing anything after the first term, you got to throw zeros in with those x's. And now we can go ahead and proceed with our usual steps. So let's divide our first terms. X cubed divided by x is x squared. So x, now we're going to distribute x squared times x and x squared times 2. And then subtract to change the signs. Cancel. Add down to have negative 2x squared. And then bring down the next term. And now we're going to divide again. First terms, negative 2x squared divided by x is negative 2x. Then go back and distribute. Negative 2x times x is negative 2x squared. And negative 2x times 2 is negative 4x. And then subtract to change the signs. If there's one huge mistake people make here, they forget to change the signs on the second row each time. And then it screws up the rest of the problem. All right, now add down and bring down your last term. And then start dividing again. First terms, 4x divided by x is 4. And then distribute 4 times x. And then 4 times 2. And then subtract to change the signs. Now we are going to get a remainder here of negative 16. So we're going to put minus 16 over x plus 2. That's the formal way of showing a remainder. So the quotient here, we would say the quotient is x squared minus 2x plus 4, and the remainder is negative 16 over x plus 2. I think we're good there. I've shown about 6 examples already. Now we're going to get into the next part, which is using synthetic division to find the quotient and the remainder. Now, synthetic division, the word synthetic means like almost like fake in a way, not the purest way. So, or it's kind of like artificially made type of thing. So the thing about synthetic division, it doesn't work all the time. We can only use synthetic division when we're dividing by numbers like x plus 3 or x minus 2. We can't use synthetic division when we're multiplying by a trinomial, or we can't use it when we're dividing by like 2x plus 3. We can't use it when we're dividing by x squared minus 7. Okay, it needs to be in that pure form, x plus a number or x minus a number. Okay, so as I said, it's not like a true thing that you can use all the time, or else I would have never taught long division. Long division takes longer. This one is a shortcut because it's only dividing when we're doing the special types. All right, so use synthetic division to find the quotient and the remainder. So we're going to be dividing by x plus 3 here. So what we're going to do is set up a little box on the side, and we're going to put -3. Now, -3 represents, why did we use negative? Because if we're trying to divide by x plus 3, if we were to see if that is a root of 0 on a graph, we would be checking the x-axis at -3. So, in other words, whenever you have a binomial x plus or minus a number, you got to put the number with the opposite sign for synthetic division only. So now we're going to put the numbers for that longer, polynomial. Now, you can see what the 2 and the 7 represent. Notice the 0, that represents the missing x squared, and the 1 represents the x. So now, now we're ready to do synthetic division now that we set this up. So whenever we do synthetic, we want to drop down the first term, the 2. And then it just turns into multiply, add, multiply, add, multiply, add, multiply, add. So we're going to multiply -3 times 2. And that'll be -6. We line it up under the next number. And then we add them together. 7 plus -6 is 1. Now we're going to do -3 times 1 is -3. Line it up under the next number. Then add those numbers. 0 plus -3 is -3. Now multiply again. -3 times -3 is 9. Line it up under the next number. Then add down. 1 plus 9 gets 10. And then -3 times 10 is -30. And then add them together. -12 plus -30 is -42. And we're stopping there. There's nothing else to multiply. We went through our last terms. So now we have to make sense of these numbers here, these 5 numbers on this bottom row. Now, what we're going to do is we're going to turn it back into a polynomial. The last number is always the remainder. Always, always, always. And then the other numbers can get turned back into a polynomial. So this must be, if this is the remainder, this must be the constant, the one without the variable. This must be the x term. This must be the x squared term. And this must be the x cubed term. So we'll put this looking real nice. 2x cubed plus the 1x squared minus 3x plus 10. And for the remainder, you just do a minus for the -42. and then 42 over x plus 3. And there's your answer. Okay, let's try another one. So we're dividing by x plus 2, so put a -2. When it has a binomial, put the opposite. And then the numbers will be 1 for the x cubed. And notice the 0 I have to throw in there because it's missing an x. You got to be careful with that when you're doing your quiz and homework. Got to be careful with 1s and 0s. All right, first term drops down. First number always drops down. Then we multiply. -2 times 1 is -2. Then add down. Then multiply. -2 times -4. Then add down. Then multiply. -2 times 8. Then add down. So now we're going to put this back into a polynomial. The last number is always the remainder. And you can see to the left the remainder is a constant. This would be the x term. This would be the x squared term. So 1x squared minus 4x plus 8 with a remainder of -27 over x plus 2. Remainders are formally written as fractions. Okay, let's try another one. We're going to put 1. It's the opposite of x minus 1. And then 1 for the x to the 4th, 0x to the 3rd, 0x to the 2nd, 0x, and then finally the -1. So first term drops down, then multiply. 1 times 1, add down. 1 times 1 again, add down. 1 times 1 again, add down. 1 times 1 again, add down. So let's put it back into a polynomial. We don't have a remainder here, so we can just not worry about that. So we would have to have the constant x squared, x cubed. So this would be 1x cubed plus 1x squared plus 1x plus 1. There's your answer. Okay, using synthetic division, determine whether the numbers are zeros of the polynomial function. So we have two parts here in number 31. We have two problems. We're testing if each of these are zeros using synthetic division. So -3, we're looking for a yes or no answer, and then 2, we're looking for a yes or no answer. Now these guys, the -2 and the 3, are not given to us as binomials with an x in it. So don't do the opposite thing here. So we are actually going to test out -3. If it said x minus 3, then we would do the opposite thing. All right, so 3, 5, -6, and 18. So drop down the 3. Negative, now multiply. Multiply, add, multiply, add, multiply, add. -3 times 3 is -9. Then add. -3 times -4 is 12. Then add. -3 times 6 is -18. Then add. The 0 is the remainder, so just get rid of it. And this, you can see, is 3 terms, so that would be a trinomial. 3x squared minus 4x plus 6. Actually, I didn't need to do that. It didn't say find me the quotient. It just said I got to be careful with directions always. Even myself, I got to go back and read a second time. Good thing I caught myself, because the directions say determine whether the numbers are zeros. So number 3, for the -3, we're going to put no. -3 is not a 0. Okay, now let's test the 2. First number drops, multiply 2 times 3, then add 2 times 11, then add 2 times 16, then add. So the 40 is a remainder. I'm sorry, I gotta go back to 31, the first one. I apologize, I should have put yes here. It is a 0. A 0 is a factor. I should have put yes. Again, I apologize. So I don't really do editing of videos, or else I would edit that out. When you have as we learned earlier in this lesson, when you have a remainder of 0, you put yes, meaning it's a 0 or a factor. So going to this one, 2 is going to get a no because it has a remainder that's not 0. Therefore, it's not a factor, also known as not a 0. Okay, almost done. Last one. We got 2 more to test out. So I'm going to test -3. Again, don't do the opposite thing here. This does not have an x with it, so do the number as is. All right, I had no missing terms here, so no need for zeros. Notice the x to the 4th gets a 1. So first number drops down. So multiply, add, multiply, add, multiply, add, multiply, add. So I get a 0 here, so I'm going to put yes. -3 is a 0. Now I'm going to test -1, or sorry, not -1, +1, to see if that's a 0 of h of x. First number drops down, multiply, add, multiply, add, multiply, add, multiply, add. And we get another yes. We got another remainder of 0, so 1 is also a 0, also known as a root, also known as a factor. All right, guys, that's the end of the lesson. Feel free to rewatch this video or ask me questions during class, or feel free to look up on YouTube. The first part was polynomial long division. The second part was synthetic division.